Today we're going to jump into probably the toughest part of factoring. Um, Depending on who your teacher is, you might get taught several different ways. There's a thing called the box method. There's a thing called the bottoms up. This is called the master product, and I've also heard it called the split method. All right, so we'll just jump right into this. So we're factoring a trinomial, and you'll notice this trinomial, unlike the ones we've dealt with so far, has a leading coefficient of 3. So we cannot just find the factors of 21 that can become 16 because now we have a 3 in the mix. So let's talk about what we can do with this. Like I said, this is something called the split product, master product, if you want to look this up for your own. The way that we do this is we are going to multiply the A, and I've also heard this called the AC method for the same reason. We're going to multiply the A term times the C term. So we are going to multiply 3 times 21, which gives us 63. So where we normally found the factors of 21, that could become 16, we are going to focus on the number 63 instead. So let's find all of the factors of 63. And again, we're looking for the factors of 63 that can become 16. So 1 times 63, of course, 3 times 21, and then 7 times 9. And 7 times 9 is where the search ends. Because 7 times 9 both multiplies to equal 63, and it adds to equal 16. So here's what we're going to do. What we're going to do is convert 16 into a different version of 16. So our 16x is no longer going to be just 16x. We're going to turn it into 7x plus 9x. Doesn't matter which order we put these in. As I look at it now, I wish I would have put the 7 on the other side, but it really does not matter. And we all understand, hopefully we see that 16x is 7x plus 9. We're basically doing the complete converse of combining like terms. We're breaking these two terms up, and we have a means to an end here. And this is why we call it, it's also called the split method here, because we're splitting the 16 into two terms. So now we have 4 terms. If you remember from yesterday, anytime we have 4 terms, we need to start thinking about factoring by grouping. So I'm going to factor by grouping. So I put these 2 terms together. First 2 and the last 2 go together. And I see between the 3x squared and the 7x, the only thing that they share is an x. And remember, you will always be able to factor out something, because even if the numbers don't have a common factor that you see, we can still factor out a 1. Now in this case, they both have x's, so we're fine. And we factor out an x from 3x squared, and we get 3x. We factor out an x from 7x, and all we have is 7. Now when we look at this, just like I told you when we did factoring by grouping, this is a huge clue to what we should see on the other side, because either it's going to match up with a 3x plus 7 or it's not factorable. So let's think about this. What turns a 9x into a 3x? That would be factoring out a 3. So I look over at the 21 and I see this 3 going to 21. Of course it does. So I kind of used my second part to guide me towards my factoring. So when I factor out a 3 from 9, I get 3. The x is still attached, and when I factor a 3 from 21, I have 7. So I accomplished what I hoped to accomplish, and it should work this way all the time, because remember, 7 and 6 are not just random numbers. I chose those 2 numbers for a reason. So they should match. Now we have combining like terms here. We have a term that's being multiplied times 3x plus 7, and we have a second term being multiplied by the same amount. So what I'm going to do is take those two terms, the x and the 3, and I'm going to combine them and multiply one time. Now, the tendency for students is to want to come in here and say, well, this is 3x plus 7 squared. But remember, we didn't multiply here. Exponents only change when we multiply, and this was addition. This was essentially combining like terms. Now, if you do not feel good about your answer, what we're going to do is you can use the distributive method to check your answers. We could distribute x times 3x, this is 3x squared. X times 7 is 7x. Move to the 3, and this should seem very familiar because that was our previous line, but you can see that once I check my answer, we end up with what we started with. So this is another method that we could use to check that our factoring was done correctly. All right, so we're going to take a look at one more example. And this one I purposely chose because we do have a subtraction sign. We got to make sure that all of our signs are good. So we are going to first multiply our A value times our C value. A value being 5, C value being negative 21. So the number we're interested in is the factors of 105, and in this case, negative 105. What I'm doing right now is a hint that I gave you earlier. I don't know the factors of 105 so great, so what I'm doing is I'm going to my calculator and putting in y equals 105 divided by x. And then when I hit second table, I'll be able to see all of the factors of 105 quite easy. So here we go. 105, of course. 2 is not 1. 3 times 35. Again, I'm just looking down my list here. 5 times 21. 7 times 15. And 7 and 15 can become 8, but I'm going to just keep looking down the list, make sure nothing else works. And the next one I see is 15 and 7. So I've seen all of the factors. The only ones that can become an 8 are 7 and 15. I need it to be a positive 8, so the 7 is going to have to be the negative one, and the 15 has to be the positive. If I did it the other way, then it would have ended up with a negative 8, which is not what I want. So here we go. We are going to change our 8x into a different version of 8x. And that version in this case is going to be 15x and negative 7x. Now, I'll tell you this right now. When given the opportunity, I believe you want to put the negative sign in the front. So I'm going to put negative 7x and positive 15x. You do not have to follow that rule, but trust me on this, it's a little easier when the negative sign is not the first term in the grouping. So the other two terms, the 5x squared and the 21, are just going to be carried down. Just like we've said, for terms, we should be thinking factoring by grouping. So I'm going to group the first two, and I'm going to group the second two. So see, I put the negative in the first slot because now I can use this plus sign to remind me that this is not multiplication, this is adding and subtracting. So as I look at my left term, 5x squared minus 7x. Well, the only thing those two prime numbers share is an x value. When I factor out an x from 5x squared, I get 5x. And when I factor out the x away from the 7x, it's just minus 7. Again, I love to use this term right here as my little cheat sheet. Remember, I'm the one that chose 15 and -7. I chose them because they actually work. So, having said that, if I chose wisely, then this second parentheses should match the other one. Now, I can't just blindly write this down, but I'm going to see, okay, how do I make a 15x become a 5x? Well, I would do that by factoring out a 3. And I'm also needing a -21 to become a -7, and 3 is also the answer to that puzzle. So there we have it. We have like terms. 5x minus 7 and 5x minus 7. So when we have like terms, remember we are going to combine those terms, x plus 3, parentheses, very important, and multiply one time. So this again is what I've heard called master product, AC method, split method. Can't think of any others off the top of my head. Guess and check is another way that people have learned. Bottoms up, and then the box method. This is my favorite. Box method would probably be my second favorite. Reason why I like this one is it factors completely, and even if you don't pull the GCF, you can still get it correct. All right, guys, these can be a little overwhelming. Just take them a little bit at a time. You've got your Delta Math assignment posted already. Good luck.